What's up, dear students, and welcome back to a new video of grade 11 physics. Now, I know it has been a while, but don't worry, I have promised and I mentioned in the videos that I'm going to be with you throughout the series for grade 11. We have relative motion in the final section of chapter 2, which is section 4. We have frames of references and relative motion. Now, in chapter 1, you studied that in order to calculate the motion of an object, we need a frame of reference. Now, frame of reference is basically a coordinate system in which you can measure the position, the velocity, the acceleration, the motion of an object in general. Okay? Now, sometimes we can take different frames of references for the same object. Okay? So let's imagine you have two cars. Okay, you're driving, and there is a car in front of you. You are going with a speed of, let's say, 80 kilometers per hour, and the car in front of you is going with a speed of 90 kilometers per hour. Now, if I ask you what is the velocity of the car, or what is the relative velocity of the car in front of you, you're going to say it's equal to 10 kilometers per hour. Okay? So that car is going 10 kilometers per hour faster than you. Let me give you another example. Let's say there are two people on a train. Okay, one of them is sitting here. Okay, let's say there is someone here. Okay, sitting. And then there is also somebody here who is walking. Okay, there is someone here and they are walking. Okay, now let's say this guy is going with a speed of 5 meters per second. The train itself is going with a speed of, let's say, 30 meters per second. Now you are here and you are observing. Okay? You are here and you are observing the motion of this guy. Now, relative to this guy who's in the train, the speed of this one is 5 meters per second. But relative to you, the speed of this guy, this one, is 35 meters per second. So look, we took two different frames of references and we got two different results. Okay, so this is basically relative motion. Let's give another example. This is a really good example. If you are on an airplane and you throw a basketball or a ball, now to you the ball is what is going down on a straight line. Okay, so let's say this is an airplane. You throw a ball, okay, and this ball to you, relative to you, is going down on a straight line. But relative to someone who is not on the plane but is on the earth, okay, so let's say this is an observer and he is looking at this ball. This ball is going to be moving on a projectile motion. Okay, so this is what this guy is going to see, like a projectile motion, a parabolic motion of the ball. Okay, so we took two different references, we got two different results. Okay, now this is basically it. What equation do we use to calculate the relative velocity of an object or the relative motion of an object? Let's say you have this car compared to this car. Okay, we're gonna say the velocity, okay, for this car, the velocity of the car, look, we have the velocity of the slow car relative to Earth. Okay, so this car relative to Earth is going with a speed of 80 kilometers per hour. This car here, this is not VSE, by the way, it is VFE. Okay, so the velocity of the fast car relative to Earth is equal to 90 kilometers per hour. Now, if I ask you what is the velocity of this car relative to the slow car, we have an equation for this. So the velocity, look at here, the velocity of the fast car relative to the slow car is equal to the velocity of the fast car relative to Earth subtracted by the velocity of the slow car relative to Earth. Okay, I think this is the only thing that you need to know here. You don't have to overcomplicate things. Okay, these are different examples. It says a boy bounces a rubber band in an elevator that is going down. If the boy drops the ball as the elevator is slowing down, is the magnitude of the ball's acceleration relative to the elevator less than or greater than the magnitude of the acceleration relative to the ground? Greater than, because the elevator is accelerating upward as the ball falls. Okay, so look, you have two different frames of references. Okay, and this is also another question. Let's move on to sample problem 2F. It says a boat leading north across a wide river with a velocity of 10 kilometers per an hour. Okay, now we're gonna say what it says, 10 kilometers relative to water. So we have what? We have a boat like this. It is going north. We're gonna call this velocity of the boat. You can say river, you can say water, it doesn't matter. Okay, it's just basically words, or just to remember what velocity is that. So velocity of the boat relative to the water is equal to 10 kilometers per an hour. Okay, the river has a uniform velocity of 5 kilometers due east. So the velocity of the velocity of the river, we're gonna say relative to Earth. Be careful. The velocity of the river, because it doesn't say relative to anything, so you're just gonna say relative to Earth, is equal to 5 kilometers per hour. You know these two are perpendicular, so my resultant is going to be like this. It says what? Determine the boat's velocity with respect to an observer. If it says relative to an observer, it means relative to Earth. So we're gonna say what is the velocity of the boat relative to Earth is equal to what? Or you can basically say O instead of E. Instead of Earth, we're gonna say observer. It doesn't matter. Now you know velocity of the boat relative to the observer is equal to what? Is equal to the square root of the velocity of the boat relative to the water. So VBW squared plus velocity of the river, because this is what? This is y and this is x. Okay, and you know how we use Pythagorean theorem. Velocity of the river relative to Earth squared. Velocity of the boat relative to Earth is equal to what? Or relative to an observer is equal to 10 to the power of 2, or 10 squared plus 5 squared. Velocity of the boat relative to an observer is equal to 11.18 kilometers per an hour. Okay, if you want to find the direction, it's really easy. Theta is equal to what? So this is the angle basically. Okay, theta is equal to tan inverse of what? Of opposite. This is opposite the angle. Opposite divided by adjacent. So opposite is what? Is VRE divided by adjacent. Velocity of the boat relative to the water. So tan inverse is 5 divided by 10. I get 26.6 degrees. This is sample problem 2F. Sample problem practice 2F, sorry. A passenger at a rear of a train traveling at 15 meters per second relative to the Earth. So the velocity of the train relative to the Earth is equal to 15 meters per second. If someone throws a ball in the opposite direction of the train, so the velocity of the ball relative to the train is equal to 15 meters per second. What is the velocity of the basketball relative to the Earth? So what is the velocity of the basketball relative to the Earth, or relative to an observer? We're going to say velocity of the ball relative to the Earth is equal to velocity of the ball relative to the train subtracted by the velocity of the train relative to the Earth. 15 minus 15, the velocity of the ball is 0 meters per second. So guys, you basically have a train which goes at a speed of 15 meters per second. Okay, like that. If you throw a ball at the same speed, but in the opposite direction, what is the speed of the ball relative to the Earth? Of course, it's 0. Okay, why? Because both the train and the ball are moving at the same speed. Let's say this time you throw a ball at a speed of 20 meters per second. This time you're gonna get what? You're gonna get 5 meters per second which is the velocity of the ball relative to Earth. Question 2, it says, a family went on a sea tour in Beirut. If Hiwa runs to the back of the boat at a speed of 3.5 meters per second. Okay, so this is going to be Hiwa's velocity relative to the boat. So HB Hiwa, B is the boat, is 3.5 meters per second. If the speed of the boat, this is going to be velocity of the boat relative to the Earth, is equal to 18 meters per second. What would Hiwa's speed be with respect to an observer? I told you with respect to an observer is what is velocity of the Hiwa relative to Earth is equal to what? So velocity of Hiwa is equal to what? Is equal to 18, so velocity of the boat relative to Earth subtracted by velocity of Hiwa relative to the boat. So 18 minus 3.5, you get 14.5 meters per second. Okay, now so basically when you have two objects that are on the same direction, you're going to basically subtract them. If they're approaching each other, you're going to add them together. If a ferry boat is crossing a river, okay, if the ferry is headed due north with a speed of 2.5 meters per second to the water, so you have what? You have this, okay? This is the velocity of the ferry relative to what? Relative to the water or the river is equal to what? 2.5 meters per second. And the river's velocity, look, is to the east. Okay, so the velocity of the river relative to the Earth is equal to 3 meters per second. You know these two vectors are perpendicular. The question says, what is the boat's velocity relative to Earth? So the velocity of the boat relative to Earth is equal to what? You know, velocity of the boat is equal to square root of this one, 2.5, plus square root of this one, 3 squared. Okay, velocity of the boat relative to the Earth is equal to 3.9 meters per second. Okay, now this is the angle, okay, theta. Theta is equal to tan inverse of opposite divided by adjacent, so 3 divided by 2.5, you're gonna get 50 degrees. Question 4, guys. You have a pet store supply truck moves at 25 meters per second north along a highway. Inside, a rabbit moves at 1.75 meters per second at 35 east of north. You have an angle, just analyze this into two vectors and add it with the velocity of the truck, okay, and find it, okay? And I don't think that question is really that important. I'm gonna move on. Question 1, it says a woman on a 10-speed bicycle travels at 9 meters per second relative to the ground. So the velocity of the woman relative to the earth or ground, you can say g, it's fine, 9 meters per second. She passes a little boy on a tricycle going in the opposite direction. Okay, so she passes, look, this is the woman coming and this is the boy. Okay, so the velocity of the boy, okay, relative to the ground is equal to 1 meter per second. Okay, what is the velocity of the boy relative to the woman? Because they're approaching each other, okay, so we're going to say what? Velocity of the boy relative to the woman is equal to velocity of the woman relative to earth plus velocity of the boy relative to the earth. 9 plus 1, you get 10 meters per second. Question 2, a girl at an airport rolls a ball north, okay, so we know that it is north, okay, and a walkway that moves east, so the walkway moves east. if the ball's speed with respect to the walkway is 0.5 meter per second, okay? So the ball was going where? The ball was going to north, okay? Before that, we know that we have what? We have the walkway, okay, which is moving east, okay? So we have the walkway moving east, okay, is equal to 1.5 meter per second, okay? And we also have what? We have the ball, which is moving where? Which is moving to north, which is equal to 0.5 meter per second, okay? Just find the angle and the resultant, or the velocity of the ball relative to the ground, okay? So first we have what? The velocity of the ball relative to the walkway is equal to 0.15 meter per second. We also have the velocity of the walkway, okay, relative to the earth, which is equal to what? Which is equal to 1.5. It says, what is the velocity of the ball relative to the earth? Okay, so what do you have? We have velocity of the ball relative to the earth is equal to, my screen is lagging and it's really annoying me. Let me refresh that. Okay, I'm sorry. So you basically have two vectors that are perpendicular. We said that we're going to use Pythagorean theorem, okay? Now velocity of the ball is equal to 0.15 squared plus 1.5 squared. This is going to give me 1.5 meter per second, 1.51 meter per second. Find the angle. The angle is equal to tan inverse, okay, 0.15, okay, divided by 1.5, okay, you're gonna get 5.7 degrees. This is question 2. I'm gonna leave the other questions for you. As I said, I'm really sorry that the videos are coming out late. I'm trying really hard to make the videos as soon as possible. Just one simple advice, if you have time you can listen to it. If you don't, you can just skip it and go on with your studying. When you solve practices and problems in physics, please solve them many times. For example, we have this sample problem here, okay, this one here. If you have the slightest hesitation that you don't know what the question is about, if you have the slightest hesitation that you don't know the equations, you don't know the givens, you don't know the unknowns, please go and revise, okay? If you are not comfortable with these sample problems, then you have problem solving the questions, okay? Solve them many times until you become really comfortable with the equations. Many students are complaining that they don't know what the question is asking, they don't know what the givens are, they don't know what the unknown is. The problem comes from students not really practicing, okay? You should really have a paper and a pen in your hand. Write again and again, solve the question and again until you are really comfortable with the equations. Okay, in chapter 1 and chapter 2, we studied many equations. Okay, I know you are too annoyed by these too many equations, but believe me, if you don't solve them, if you don't memorize these equations. And how do you memorize them? By writing them again and again, solving questions many times, and then you'll be comfortable with the equations. Because every day, every lesson, you are facing and encountering new equations. Okay, so you basically are going to have a pile up at the end of the chapter or at the end of the section. Okay, so don't ignore anything. Something else students are really ignoring, and I always tell my students, which is that they don't know what the topic is. So they don't read that this is relative motion. Okay, they just basically start section 4 without knowing what the topic is really about. They don't read the head of the topic, okay? For example, let's say you have a table in your hand and you have memorized everything in that table. So remember, for example, we had many equations for uniform acceleration. V final was equal to V initial plus A delta T. Okay, then V final squared, you know the equations. Yeah, you have memorized these equations, but you didn't read what the table is about. Okay, you didn't read that the table was about uniform acceleration equations. Yeah, you have done your best. You have put plenty of effort to memorize these equations. You have memorized the equations of free fall, but you didn't read that it was about free fall. Please read the topic, read the head of the topic, the subject, and then start memorizing and practicing the questions. Because if you don't know what the topic is about, there's no point in memorizing all these equations. Okay? So for example, if you memorize this equation and you don't know what this really is about, you don't know that this equation is for relative motion, then there is no point in that. Okay? So please care about and be really cautious with the topic, with the subtopics, of course. Practice and solve the questions again and again. Don't say that I have solved this question and I know that it's already solved. No, cover the solution, okay, and then solve it again and see if you can really get this. Something else that students are really not caring about is the calculator. Please learn how to use the calculator, because it's really a pity that you have studied everything, you know the equation, you know the steps, you have followed the steps correctly, you know the math behind the physics here, but you don't know how to use the calculator, and then you're going to do a mistake in the exam and you're going to lose 1-2 marks because of not using a calculator. This is what I had to say. I hope you got some benefit from that, and I wish you a good luck in your exams. Until the next video, see you and have a good day.